Hi, everyone. Such a pleasure to be here with you today. I'll be talking to you about techniques for data minimization in AI. And also the reason why data minimization is important in AI as well. And for those of you who don't know, data minimization is a practice of minimizing the amount of personal information within your data to only what you absolutely need to be there. And it does tend to be a requirement for all major data protection regulations. First of all, when it comes to data minimization, one very important thing to know is what it is that you're minimizing. So data minimization of personally identifiable information means more than just your names and your social security numbers and your credit card numbers. It includes direct identifiers like those, but also quasi-identifiers. And some quasi-identifiers can actually be special categories of sensitive data, like political affiliation, sexual orientation. And some of these, in some cases, not only can you not process, but in other cases, you can also consider these as, or in all cases, you could also consider these as information that, when combined together, can exponentially increase the risk of re-identifying an individual. And so for data minimization, you might be concerned about re-identification of an individual. You might be concerned about identity theft, for example, or if you have somebody's credit card number as well as their name and a social security number and so on. Or you might be concerned about not processing sensitive data. It really depends on the use case that you're tackling and what kind of information that you need for that particular use case. But these are the ones that you need to keep in mind, in addition to, of course, confidential company information and the sort, when it comes to what it is that you're feeding into AI models. With regards to data minimization within AI, one problem that had shown up in the news in April of 2021 was this particular case when this chatbot company within Korea called Scatterlab had been boasting about the billions of conversations they had between users. And they had trained on these conversations without worrying about the personal information. And so they started spewing out entire names, nicknames, addresses in production. And that ended up going in the news and losing a bunch of customer trust as a result of it. With these, it was essentially a love bot, and these individuals that were using the love bot could then determine what other people had been using it as well. And before that happened, in 2019, this paper by Carlini et al. Called The Secret Share showcased how if you store a random sequence of numbers within the Penn Tree Bank database and train a character language model on it. So this a character language model will give you the next most likely character as opposed to the next most likely word. If you train a character language model with this random number inserted into the training data set, you actually can measure the amount of surprise that that model has at seeing the sequence of numbers or a random other sequence of numbers. And what you're seeing here is log perplexity, which is that measure of surprise of the model. And it is much less surprised at seeing the sequence of numbers that was stored in the training data. And you didn't need a large number of occurrences within the data set for this to happen. And so what you're seeing there is also that quote unquote memorization of the training data, even known back in 2019. And this also occurs within embeddings. And this is particularly important to point out because of the heavy reliance that we're starting to see on RAG embeddings within enterprise as well. And this particular study in 2020 showcased how within word embeddings, that were trained on and generated from a healthcare data set, the first names were closer to the last names in distance, And the names were closer to the disease that they occurred nearby. So you could extract information from the embeddings themselves just by the distance between the words. And so which disease a particular person was most likely to have been mentioned next to, in particular, was sensitive. And this more recent research paper showed that even really dense embeddings, within those, you can recover up to 92% of the original data. And in this case, it showed that you could recover important personal information, like full names, from data sets of clinical notes. So when you're creating these embeddings for your models, you also have to be cautious about that. And this concept of data minimization can actually be really tricky when you're dealing with conversational data or with real world data. And in expectation, you might have somebody in a conversation asking for your email address. And you might think that it's going to be this, sure, it's Noreen455@gmail.com. But in reality, what you're really dealing with is much more complex, with people making mistakes, having disfluencies, spelling out names and giving equivalent words that letters that start with the letter that they just said. And so you have to be able to capture all of this information when it comes to data minimization if you are intending to remove that particular piece of data from your data set. And this this is something that you have to consider when you're in multiple parts of the large language model that you're dealing with. So if you're using a large language model from a third party, you'll want to consider what kind of information you're sending to them, both for training and as well as RAG embedding creation, and also for when you're sending information through prompts to that large language model. So that's one place where privacy and data minimization would fit in. You'd also want to consider what to do with the information that you're sending through a prompt or receiving from a prompt from a user, even if the large language model lives in your environment, because they might be sending you things like healthcare information or credit card numbers accidentally that you won't want in your system. And it actually turns out that if you have a prompt, you redact the personal information or other information you want to minimize before sending that prompt over to the large language model, you could then get a response and reintegrate the information into the response of the large language model, all within your environment. And that's something that we do at Private AI, really to prevent that large language model from ever receiving the personal information in the first place and still have a seamless interaction. And then another aspect you'd have to be concerned about is that cleaning of training and fine-tuning data before it reaches the large language model for training or fine-tuning, because you want to prevent that memorization of information. Also, where you'd sanitize the data before for RAG embeddings is right before those RAG embeddings are created from that contextual data. And this can be done on a case-by-case basis, depending on which users, for example, should have access to which kind of information. It can be, of course, a little bit more expensive to do, but important if you want to maintain more fine-tuned access control to this data. And then finally, as a measure of last resort, another place you could fit in is in blocking the sensitive information or personal data from the response that's being sent to the end user. So if by accident it turns out that you trained or fine-tuned or created RAG embeddings from contextual data that contain information that you didn't expect, you could detect that at the response. Hopefully, not the ideal place to do it though. So I'll go over what to look for in a data de-identification solution slash data minimization solution because it's a pretty complex problem to solve, and it can often be underestimated with regards to how complex it is. So when it comes to a data minimization solution, you'll want to make sure that whatever you're choosing is highly accurate, really scalable, also really customizable for the entities that you are deciding to remove. And oftentimes you are dealing with multilingual data and as well as multinational data. So it has to be a product that's really adapted to, uh, for example, addresses globally and different ID numbers globally, and also adapted to the various privacy and data protection legislations that are popping up globally, as well as adapted to the various formats that you are processing, from text, audio, images, documents to semi-structured data as well. So one common thing to watch out for is if you have a structured data set, sometimes you might have a notes column. Very often you might have a notes column where you have, for example, doctor's notes or customer service notes, or a free text field with information that you just don't know what's in there. And that's somewhere to be cautious about as well. And the reason that this is a really hard problem is that you're often dealing with really large volumes of data. So you need someone that can process that information fairly quickly. And that patchwork of privacy legislations globally is really getting more and more complex. And it's becoming more and more to keep track of. So normally what organizations do with regards to privacy and data protection regulations is they'll abide by the standards that are the most stringent, and then they'll adapt their practices from a regional on a regional basis uh, to what's particularly required for where they are doing business. And then you're often dealing with a lot of disfluencies, as I had mentioned, disfluencies in speech, also optical character recognition errors, ASR system errors. So you need to think about all of these when you're looking at minimizing your data. In addition to that, you'll also want to consider how complex the documents that you're handling are. So are there tables within the documents? Do the documents contain images? Do you need the documents to be natively redacted for your purposes? So it's really something that you should consider ahead of time in order to not be surprised afterwards about what it is that you can or cannot handle. And in addition to that, you'll want to consider whether there's any assessments that need to be made of the data sets that you're dealing with. So, for example, in the case of HIPAA, the Healthcare Privacy Act in the United States, well, Healthcare Information Portability Act. What they require when it comes to using data for secondary purposes is either using HIPAA Safe Harbor, where you have 18 different entity types that you need to remove, or the more common one is expert determination, where you have to get an expert to come in and say that the de-identification process was done well enough and is under a particular re-identification risk threshold. And this can be by removing the entities altogether, or it can be by, for example, a making ages turn into age ranges, making dates shift, and this can all be taken into consideration for the use case that you are dealing with. And depending on what kind of information you need in order to do proper research or use the data for the secondary purposes that you need. And that can all be taken into account when you're doing expert determination. So one thing that I want to point out is that HIPAA is really kind of unique in the sense that it's very specific in what it is that you have to do in order to comply with the legislation. whereas regulations like the GDPR are really leaving it up to the company to figure out that it did the best that it possibly could and report that or create reports of that and make sure that you're keeping track of everything that you think are best practices in case anything, knock on wood, goes wrong. You have that to show to the courts. And that is much trickier to do because you have to basically rely on your own um, internal knowledge to an internal stamp of approval to say that you were doing the right thing. There are two types of third-party verification, which are interesting, which you might want to use in such situations. And one of them is model verification. It's very new, and the other one is the data set verification, like the HIPAA expert determination, which it doesn't matter if it's if, for example, you're not trying to comply with HIPAA, but you're trying to comply with the GDPR. Uh, you could still get an expert to come in and say that what the re-identification risk assessment is for a particular data set. And so I'll give an example of this one, this model assessment. Uh, we went through this process with Armilla. They're backed by Swiss Re. And they tested out performance, bias and fairness, robustness, and processes and governance of our models. And now there's also a warranty that we have for the models that were assessed by Armilla, which I think is really cool because there is a lack of certifying bodies when it comes to doing the right thing within this space. So I would recommend if you are doing something of the sort, depending on model security or depending on data set privacy, to have some sort of third-party assessment, because this might go, hopefully, a long way when it comes to talking to regulators, as well as clients, and as well as showing clients that they can trust your solution. And then when it comes to HIPAA expert determination, there are third parties that you can also use, like Asian, to do that expert determination for particular data sets. And they'll measure the re-identification risk, and they'll say whether or not you fall underneath the expected threshold for HIPAA expert determination. But it doesn't necessarily, as I mentioned, have to be for HIPAA, but that is something to discuss with your expert determination provider of choice. So I'll leave it at that. If you have any other questions, or if you have any questions about anything that I've said, or data protection legislation as it relates to AI, I'm more than happy to connect on LinkedIn. And please write me a note saying that you had questions from this presentation. Thanks so much.